Hello students, let's read the problem. And it says, what is the equation of the asymptote in the exponential function f of x equals negative 2 parentheses 1/4 of x plus 5? Okay, so I'm looking for the asymptote, right? Now, do you know what that is? What's an asymptote? Okay, so an asymptote, it's kind of like an imaginary line that your function, your exponential function, will kind of like approach but will never touch. Okay, and later on in pre-calculus and calculus they call that kind of like limits, but right now I want you to think about it from this perspective. If I was to draw, if I was to sketch, or if I was to put this on a grid, right, graph it, how would that look like? Okay, so this basically means that my function will kind of like approach a certain number, right? But it will approach it in a way that it will never ever cross it. Okay, so what number is that one, right? Okay, so let me go ahead and write down my function, my function notation, right? So this is going to be f of x equals negative 2 parentheses 1/4 to the x power plus 5. So what I'm going to ask you to do is, let's go ahead and kind of forget about the plus 5. Let's go ahead and focus on that one, right? Well, how would that look like if I was to graph it? Or what is it that each one of those elements it will do to my function, right? Well, the function itself will approach 0, right? It will approach 0, but now we have a plus 5. So if my exponential function by itself is approaching 0, but then I'm adding a 5, then that means that my exponential function will kind of like approach the positive 5, but will never cross the positive 5. Okay, so that means that positive 5 is actually our asymptote. Okay, so let me go ahead and show you on the graph how would that look like. Okay, now first of all, I do see that my a, because remember this is my a, it's a negative. Okay, so that means that my exponential function will not look like this, because this one is a positive growth, this is a decay, right? But since this is a negative, okay, then more than likely it's gonna be like this one, but the opposite of that one, something like this. Okay, now think about it. Why? Because b is actually less than 1, right? But of course it's greater than 0. Okay, so if b is less than 1, then this is supposed to be kind of like a decay, and this over here will be a decay for us. But the negative a is gonna make my decay kind of flip to the other side. Does that make sense? Okay, so that means that, and the plus 5 is my asymptote, which means that there's gonna be kind of like an imaginary line here, exactly at positive 5. Okay, so what we're gonna prove is, why do we say that 5 is the asymptote, right? So the first thing that I want to do is I want you to replace x with a 0, okay? Because I'm trying to find the y-intercept, okay? So we're gonna work it out up here since we already have the problem. So we're gonna say f of x equals negative 2 1/4 to the 0 power plus 5, okay? So anytime that you raise something to a 0 power, it's equals to a 1, right? Therefore, this would be equals to f of x equals negative 2 times 1 plus 5. And that will give us what? Negative 2 times 1 is negative 2 plus a 5 is a 3. So when x is 0, y is 3. Therefore, there is going to be such a point here, right, that my graph is going to go through that one. Okay, and let's suppose you want to replace x with a 1. If you replace x with a 1, that will give you a y value of 4.5. You can do the math, you can work it out. I just want to give you more or less that basically my function or my exponential function is going to look something like this. And it will be approaching the positive 5, but it will never ever touch it. Okay, so that's how my exponential function will look like. So my asymptote, it is a positive 5, because remember, the asymptote is that imaginary line that my graph can never ever cross. Okay, and therefore my answer is letter A for this one. Okay, very good.